Let's do some math. Welcome to 6.5. We're going to learn a new way to basically factor. We use factoring, especially in this unit. We use factoring to solve polynomials, right? To find their zeros, to find what multiplies into that polynomial to make it a polynomial. Because once we factor it, it's very easy to find the zeros, right? You use your zero product in order to solve it. Factoring is very important because finding zeros is very important. You're breaking down a polynomial. And these are the main ways we know so far and how to factor. GCF, right? If I gave you two terms, if I said 2x squared minus 4x, I could factor out a 2x because they both share a 2 and an x. What they would factor into would be pull out the 2x, which is left with x minus 2. That's factoring via GCF. It's the most basic form of factoring. If they all share a common term, pull it out. Trinomial factoring is what we've been doing since Algebra 1. If I told you x squared minus 2x, let's say minus 8, right? What two numbers multiply to 8 that add up to negative 2? That's going to be negative 4 and positive 2. Because negative 4 times 2 equals negative 8, and negative 4 plus 2 equals negative 2. Difference of two squares, if I said x squared minus 9 was a polynomial, right? You're missing the b term, but this is a perfect square, this is a perfect square. They're both perfect squares, which means x plus and minus 3 are my two factors, right? Because x squared, what two numbers multiply to negative 9 that add up to 0? 3 and negative 3. Fourth degree trinomial factoring, this is what we learned last video, but if I said x squared, x to the fourth, minus 3x squared, minus 18, for example, right? Two numbers that multiply the 18 that add up to negative 3, and you make sure your square term is coming first. X squared minus 6, x squared plus 3. Because negative 6 plus 3 equals negative 3, and negative 6 times 3 equals negative 18. Factoring right grouping. This is something we also learned last unit or section. Please make sure to follow up on what we just did with that. And lastly, we're learning today synthetic division. Synthetic division and substitution are the same exact thing. Remember, we were practicing this last week or 2 weeks ago. We're going to use it in another manner. The same exact process, different application. Let's jump to it. Use synthetic substitution to find f at negative 3. So we're basically going to plug in negative 3 and see what my output is for this polynomial, right? Synthetic substitution, create your box, write your coefficients. Negative 1 is my cubic. 0 is my x squared because there's no x squared term right there. 5x minus 4. Valuing at negative 3 because it's asking me to. Drop your negative 1. All of a sudden, negative 3 times negative 1 gives me positive 3. Add them up. Negative 3 times positive 3 equals negative 9. Add them up. And negative 3 times negative 4 equals positive 12. Add them up. Boom. That's my answer. If I plugged in f at negative 3, it would equal positive 8. Very nice. Let's move on. We could factor polynomials and find their x-intercepts with synthetic substitution. And here's how we do this. If you know a factor of a polynomial, then that factor means that value, the k value, whatever the factor is a 0 of the polynomial. Now, this is something we already know. What this means in layman's terms, if you will, is if I had two factors, x squared plus 2 and x minus 3, and that was my function. Now, I have two zeros for this polynomial. Right, the k value is the x equals 3 and negative 2. Because if I use zero product property, we set both these equal to 0. Notice x plus 2 equals 0, x minus 3 equals 0. You flip them over the other side, it's the opposite signs of what we did. We already knew this. In factored form, that's what it looks like. However, it won't look like factored form when we're doing these processes. We multiply it out, put it in standard form. So what this function is going to look like, x squared minus 3x plus 2x gives you minus x minus 6 is what's look like. Which means this is my polynomial right here. These are my factors of the polynomial. And if I plugged in f at 3 into this polynomial, I will get 0. Notice, I'll do it right now. 3 squared minus 3 minus 6. I'm just plugging x equals 3, which is one of my two zeros that we already determined. 3 squared is 9. 9 minus 3 minus 6 does equal 0. Same thing applies to negative 2. Negative 2 minus negative 2 minus 6. Negative 2 squared equals positive 4. Minus a negative 2 becomes plus 2. 4 plus 2 minus 6 does equal 0. Ching, ching. You already knew this. What this is saying is if you have a factor of a polynomial, it has a 0 at that same value, just opposite sign. If your factor is x plus 2, your 0 is minus 2. If your factor is x minus 3, your 0 is positive 3. That's all that theorem is trying to state. I'll write that down verbatim because I'm about to erase it. Please reverse back in time. If you need to copy that down, it is very important to understand. A factor and a 0 are very closely related. They're opposite signs, but they're the same exact thing. So let's hop to it. If you know x plus 3 is a factor of this, we could write it in that polynomial factored form. The way you do that is you use synthetic division. Synthetic division is the same thing as synthetic substitution. Same thing, but with synthetic division, we could take it another step. Right, we're using this to factor, and I'll show you what I mean when I say that. Let's put this over here. So basically, if x plus 3 is a factor, x equals negative 3 is a 0. That's what that means right there. That's what this factor theorem tells us. Which means I'm going to take this polynomial and pull out that negative 3. Negative 3 is a factor. These are my coefficients, 2, 11, 18, and 9. Just like that. Perform your operations. Drop your 2. 2 times negative 3 is negative 6. Add. 11 plus negative 6 is 5. Negative 3 times 5 is negative 15. Add. 18 plus negative 15 equals 3. And 3 times negative 3 equals negative 9. 9 plus negative 9 equals 0. Ding, 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 ding. When you have a 0 as your final term in synthetic substitution. The remainder. That means that the value you divided at is a you divide at is a 0 or solution to the polynomial. Right? We already knew it. It tells us x plus 3 is a factor. When your final answer is 0, which it was right here, it tells me the negative 3 is 0. We just confirmed it. They told me it was, but now it is. And lastly, what that also tells you, the remaining coefficients from your division, synthetic division, are the coefficients of the remaining factor. This is what's so cool about it, right? I'm going to show you this. I'm going to pick this whole problem and pull it up here. Right, the 0 tells us that that's minus 3 is a solution. Right, if you plug in negative 3, you get 0. That's what it means. So x plus 3 is that factor. We pulled it out. And this is what's left. 2x squared plus 5x plus 3. How cool is that? There's my 2x squared, because that 2, right, it basically becomes 2x squared plus 5x plus 3. Those coefficients that were down here that we used to generate that 0 become the real coefficients of my other factor. Right, up here, the top right, if I were to multiply these two together, I would get this, the original. All I did was factor. I used synthetic division to pull out x plus 3 and show you that 2x squared plus 5x plus 3 is what's left. Very cool. And you can continue to factor that by what two numbers multiplied to 2 is 2x and positive x. What two numbers multiplied to 3 is plus 3 and plus 1. All right, you could double check that. 2x squared plus 2x plus 3x equals 5x. That is my factored form of this polynomial. Boom. How cool is that? And we use synthetic division because now it's very easy for me to find my zeros. If I wanted to solve this polynomial, you set ZPP, set equal to 0, all your factors. Set x plus 3 equal to 0, which we already knew was a 0. Set 2x plus 3 equal to 0. Set x plus 1 equal to 0. You'd get negative 3, which you already knew, negative 1. And this one, subtract 3 divided by 2. Boom. How awesome is that? It's pretty awesome. We use synthetic division to pull out and factor a problem. Let's get back to it. Given a 0, x equals 2, find the other zeros of this function. So we're going to solve. We're going to factor to solve. Right? If it tells you the 0, it's not a factor. X minus 2 is the factor, but the 0 is x equals 2. So we're basically just going to use that 2. Pull it out. There goes the 2 right there. We're evaluating x equals 2. My coefficients are 1, negative 2, negative 9, and 18 because I don't skip anything. Drop your 1. 2 times 1 is 2. Add them up. You get 0. 2 times 0 is 0. Add them up. You get negative 9. 2 times negative 9 is negative 18. Add them up, you get 0. Ding, ding, ding. This 0 tells me that 2 is a 0. Now, they already told me that, but that's proof. It's proof in the pudding. If you don't get that 0, go back in and redo it. You're doing it wrong if you don't get that 0. That 0 tells me what it is. Which means, if I were to factor it out, x minus 2, we pulled out. What's left? Lower this one by 1 degree. It was cubic, right? We always lower by 1 degree because we pulled out a first degree term. It's now squared, x squared plus 0x, which you could write the 0x. I'm going to do that for just this one. Minus 9. By this 0 was only there to tell me it was a 0. Notice we don't have to write the 0x because 0x just equals 0. X squared plus 0x minus 9 just turns into x squared minus 9, which that's the difference of two squares. X minus 2 times x plus 3 times x minus 3. This is difference of two squares. what two numbers multiply negative 9 add with 0, 3 to the positive 3, which means use ZPP to solve from right here to find out x minus 2 equals 0, x plus 3 equals 0, x minus 3 equals 0. Isolate x equals 2, negative 3, and positive 3. Very nice. Two more problems. I love this stuff. These ones are just all asking the same question. Just make sure to keep up. Given that f of 4 equals negative 0, that means negative 4 is a 0, and x plus 4 is a factor. It's a cubic, so 3, 13, 2, negative 8. We're going to evaluate nicely. Drop to 3. Negative 4 times 3 is negative 12. Add them up to get positive 1. Negative 4 times positive 1 is negative 4. Add them up to get negative 2. Negative 4 times negative 2 is positive 8. Add them up to get 0. That 0 tells me good things. It tells me that negative 4 is a 0. It also tells me that x plus 4 is the factor. My remaining factor is 3x squared plus x minus 2. I can definitely factor that. What two numbers multiply to 3 are just 3x and x. What two numbers multiply to 2 are just 2 and 1. This is more positive. That goes there. X plus 4 times 3x minus 2 times x plus 1. Which means use ZPP to define the other x-intercepts. Set x plus 4 equal to 0. Set 3x minus 2 equal to 0. Set x plus 1 equal to 0. Solve in all three cases. X equals negative 4, negative 1. Here, add 2 divided by 3, 2/3. How cool is that? Lastly, here, 1, 0 is negative 2. Find the other solutions. Now, right away, all we're trying to use is factoring to solve this. You can jump right in and pull out negative 2. However, I do see they all share an x. Pull it out. You can make your life easier at any point. All we're doing is factoring. If you pull out an x, what you're left with is 3x cubed plus 20x squared plus 43x plus 30. Just like that. I know negative 2 is a 0, so I'm going to evaluate at negative 2, which means I'm only concerned with this. Now make sure, don't lose track of that x. Keep an x over here. All right, I'm going to turn this into a giant factored form. But don't lose track of the fact that x is part of my solutions. X equals 0 is a solution. Right, we pulled it out. This is what we're left with. There's 3, 20, 43, 30. Drop to 3. I'm factoring out a negative 2. Negative 2 times 3 is negative 6. Add them up to get positive 14. Multiply negative 2 times 14 is negative 28. 43 minus 28 gives me positive 15. Multiply negative 2 times 15 gives me negative 30. Add them up to get 0. Ding, ding, ding. That's once again proof that negative 2 is a 0, which means my factor is going to be x plus 2, which means in factored form, there's my x from right here. There's my x plus 2. And this we can break down into 3x squared plus 14x plus 15. Pretty awesome. We're almost done. I'm going to factor that last term again and then solve all three. What two numbers multiply to 3? This is just going to be 3x and x. What two numbers multiply to 15? It's going to be 5 and 3. And they're both going to be positive. Notice 3x times x is 9x. 3x squared. 3x times 3 is 9x. 5 times x is 5x. 9x plus 5x gives me the 14x. Good news. ZPP, set all four factors equal to 0 to solve. All we're doing is using all our factoring skills to solve in this manner. I set all four factors equal to 0. My solutions are x equals 0. We already solved that one. X equals -2, which we already knew. Subtract 5 divided by 3 to get -5/3. And -3 is my last one. Thank you for coming by. Enjoy the rest of your day.